In the previous part 1 lecture, we had created a struct and we had created student 1 and student 2. Right? And it looked very similar to this. We had struct, we had the ID field, we had a name field, we had a GPA. And if we wanted to go ahead and create a student 3 now, because of the way that we had created our struct, we'd have to actually list out the entire struct again and put student 3 here. We wouldn't want to do that over and over because we want to make it so that our struct basically becomes a data type that we can access from anywhere. Right, and that's what we'll do now, is that we'll create our own data type. Right, and there's a couple different ways to do it. Of course, it's, C. There's a couple different ways to do everything in any language. So you can create it using what's known as a structure tag. So we still have the same keyword struct, and then this tag is just an identifier name. So it comes immediately after the keyword struct and right before the opening curly brace. Right, and we have the same 3 fields in here, that doesn't change. And now we put a semicolon at the end. Right, so it now looks like this. And then we can then use it to create other variables of that type. So struct precedes the tag name, student is the tag name here, and now we can create student 1 and student 2. So in order to do that, we have to use the keyword struct when we, so whenever you define this as a structure tag variable, that's what we're doing. Here's the tag, we use the keyword struct, we use the tag, so struct student, and then here's our identifier name, student 1, and we can then use an initializer list as we did before, right, with these designated initializers for each one of these fields. And then we can also say struct student, right, so there's the keyword struct, there's the tag name, and student 2. And we know then that student 2 won't be initialized to any known values, right, it'll have garbage. And then we can just go ahead and assign student 1 to student 2 if we wanted to. We saw before that that was legal because they both have the same data type. Or we could use scanf to read information into the fields, right? Whatever our program needs to do. The important thing is we now use this tag name right after the struct. And now we can create as many students as we want. We can create student 3, 4, 5, right? As many as we want without having to rewrite this whole structure over and over again. And normally when we create these, the other examples we've created were inside main. Well, if we create it inside main, main will be the only function that can use it. We're going to want to start writing functions to access this information. So then we'll create that outside. Now, when you use the tag, we'll create that outside main. When we use the tag here, you can still do what we did before, right? Immediately afterwards, you can still create student 1 and student 2. Not a problem. So this is the only thing right here, this tag name looks different from what we did in the previous example. But it just allows us later to create student 3, student 4, as many as we want without rewriting this whole structure. Right. So actually then let's go ahead and take a look at an example with a tag before we go into the Typedef method. And let me just actually pop this up here. All right, so I've copied part of what I've given you for example 3.c, and we'll go ahead and fill in the other. Right. So here is our struct. Notice I've created this outside main. The reason I'm doing this is here. Let me show you we can create it inside main. Let's just move it inside like we had before. Right. And let's just go ahead and build this. Right. No problems. Right. Other than an unused variable. Right. But keyword struct, right, and here's my tag name, right here, student. So now when I want to define these, I say struct student, and here's student 1, and here's my initializer list. Right, and in the same way, when we printed out things before, right, I can just go ahead and print out this information if I wanted to. But I don't really want to do that. I want to write a function to do that. We've seen how to do that in a previous video. Let's move this outside here. We'll do that, and once again now, if we build this, right, this is global to the file, right? We just get the warning about the unused variable because we're not doing anything with it, but this is now global. And what's nice about this is if I want to start creating some of these structs, right, or in other functions, or I want to use them in a parameter list, I move this outside of main so it knows what this function it knows what that struct is. Right, let's just go ahead and let me fill in the rest of the code. here from example 3. What I want to do is I want to write a function then to just go ahead and print out the student information. All right. And all right, I called that print student in all caps. I change that name. Maybe follow this convention. All right. So what we're going to do is, in order to print out the student information, we have to pass the student information to the function, right? And so within the function, we're going to refer to the student by the name S, right? That's our variable name. Here, our data type name needs to be struct student. It needs to be the keyword struct and the tag name, because we created this with this tag. We want to print this out. Well, I'm just going to print out this header saying student, but we're going to print out the name, the ID, and the GPA. But within this function, since we refer to the student here as S, we just say s.name, right? s.id, s.gpa. And now we have a way to print out then any student information, right? Print out the information in the struct. So in order to call this function, we call print student name of the function. Here I'm going to pass it student1. And we'll just build and run. The system is really slow today. Right. But it passes then the student information to this function, and it prints this out for us. And if we wanted to create a second student, we could do that. Right. Struct student, student's my tag, and student2. Or instead of student2, I'll just call this one Butters. Right. And we could fill in his information. All right, and now notice I'm doing ordered and not designated initializer list. And then we could print out his information. So print student, we call that function, and we'll pass it then. Butters is the name of our variable. And if we build and no, still running. We now build and run that. Right, now we've printed out both students. Right. Very simple then to add a variable without having to recopy that whole struct, right? Simply because we added the tag here. All right, now let's take a look before we move on to the typedef of whether or not this is a pass by reference or a pass by value, right? In other words, if I wanted to modify some student information, here, let's write a function. It's not going to return anything. We'll call it modify student ID. And so now we're going to pass it a struct type student. Right, we'll call this S. And the ID field is an int, so we'll call this new ID. And in here, right, if all I do is say, right, s.id equals my new ID, and let's maybe make that a cap. Right. And while we're in here, let's just go ahead and print out the information. Right. So we're going to say printf. We're in function modify student ID. We could use the debugger as well. That'd probably be faster to step through and see this. Right. Student information is student information. Let's give this a new line. And what we'll do is now let's just call our function print student. we'll pass it S. And now, back in main, so let's just stick with our student 1 here. Back in main, let's call modify student ID, right? And we'll pass it student 1, and maybe the new ID number is 200. And then let's just print out what's in main after calling modify student ID. Student info, and let's call print again. We'll call print student, pass it then student 1, that function. All right. And let's do a run to cursor. And we'll see it in the debugger besides being printed out. All right. So with a run to cursor, right, we already printed the information the way it is, ID 101. Right, now, as we step into modify student ID, as we step into this function, right, we're just going to assign SID, the new ID number. Right, so here's what's in S right now. So next line, we see that gets assigned 200. We'll just go ahead and print that out. We'll say next line, so it executes then printing out the information. So we can see now, within this function, modify student ID, we've changed that to 200. Now, what happens when we say next line and we go back to main? So back in main, look, student ID is still 101. When we print this out, notice then it didn't change back in main. But here is the point of this. When we pass a struct to another function, it's a pass by value. All we do is we pass a copy of what's in that student information. Whenever we make changes locally here in this function, it does not change the data in the other function. If we want that to happen, we actually have to pass a function pointer to do that. Sorry, a pointer, not a function pointer. We have to pass a pointer. So here then, and I gave you this example in your example 4 code as well, the lecture examples, if you want to open that up. Right, and run that. Notice then whatever changes you make here don't affect then areas of memory outside there. Right, we'll have to write this in terms of pointers in order to do that. Right, which is another reason we learned pointers earlier. Right, because when we start passing around a lot of data stored in specific structures, we start passing pointers to structures. We don't want to pass copies of all that information. We just want to pass a pointer so that we can access the information, update it when we need to, or read it when we need to. Right. And pass by value allows us to read it. Right. But if you think about it, we're actually then, this is only one student. A lot of times we'll have arrays of student information, right? And if we had to pass a copy of, say, information about 1,000 different students, we were passing that, it would take an enormous amount of memory, depending on the size of our struct. So pointers, right? Pointers only take up 4 bytes in memory, and they point to other areas of memory. So we don't have to basically double up the memory that's on the stack. Right? So pointers are very handy, and we'll shortly learn how to use a pointer then with a struct. Right? For now then, right, what we wanted to get out of this was the fact that we were using a tag to do this. So besides the tag method, let's go to the Typedef method. And this is my preferred method. This is normally what I test you on in this class. Right? There are 3 different ways to do this. This is my preferred way, simply because it's less that I have to remember when I create a typedef. I don't have. We'll see. We don't have to type the keyword struct all the time. So here, when I call this structure typedef, we're going to use a keyword typedef, meaning type definition, and we're going to create our own data type. So notice here when we use typedef struct, right, there's no tag in this example. Yes, you can put a tag, but for right now, typedef struct, beginning curly bracket, ending curly bracket. And the name that goes at the end here, right, is followed by a semicolon. We are now creating our own data type that we can refer to by the name student, but we'll see we don't have to use the word struct with it all the time. Notice then we still have the same 3 data members. Right, so keyword typedef struct, name of our type, so the name of the data type goes here. Right. And then when we use it, right, let's just go back to the example we've currently got right now. Right. Let's just pop open code blocks and see how we make those changes. We're going to see then here, simply by saying typedef struct, and I missed the E there. Right. I'm going to get rid of the tag here. I can still refer to it as student. Now when we do that, here in main, when I want to make a student, I don't have to say struct. And when I pass things here, notice I only made the change in main. Now it's going to come up and tell me that this has already been. It doesn't like this. So now I get rid of struct here. I get rid of struct here. I made a data type out of student. So we only use then the word student to refer to the data type everywhere. We don't have to keep referring to it, or we don't have to type in the keyword struct. Right. You can use either method you want. Like I said, I just prefer the type definition method. Right. If I do a build and run, then this all works in the same way it did before. Right. It's still a pass by value. That's what this example was doing. Right. All we simply did was once we put the type def in here, right, then we didn't have to put the word struct everywhere else. Right. Otherwise, if we go back to the other method with struct and the tag, right, everywhere, if I say compile now, everywhere that I'm using student, I'm going to get an error message, right? Unknown type name student. So I then have to put in the keyword struct. So it's up to you. Right? Use this in whatever way makes more sense to you. Right? You'll need to be aware of the fact that if you're maintaining someone else's code, the difference between when you need to use the keyword struct and when you don't. Like everything else, it comes with a matter of experience. Right? And so then all of those compilation errors go away. The program runs as it did before. I prefer then creating my own type definition. And once you do that, right, our own type definition here, student, we got rid of this. Right. We were able to get rid of the keyword struct. Anywhere we use now student as its own data type. That's the difference between the two. In other words, you just use it just the same, right? We took a look at example 3 already as function parameters. We took a look at example 4 to see that it was a copy by, pass by copy, right? And we could take a look at example 5 as well too. You pop that open. Actually, example 5 is exactly like this. It uses the type def with a struct. So we've already looked at example 5. All right, what we want to do next in the next then video segment is we'll take a look at how we can then use structure pointers. That will be our next topic. So that is in the part 3 lecture.